Welcome to the Ecomodernist channel live. We are now broadcasting every Sunday at our usual time. So that'll be 11 a.m. Pacific, 2 p.m. Eastern. Thanks so much, everybody, for joining us. I've got a few of our regulars even followed us to Sunday. Today we have Gabe Ignetti, Tim Larson, and our special guest, Dr. Kevin Folta, to tell us about the future of agriculture. Dr. Folta has been active as a science communicator, especially relating to biotechnology, and he hosts the ever-popular Talking Biotech podcast, which is billed as a science-based assessment of new technology about the future of food. Welcome.
Yeah, no, thank you for having me back. This is great.
Dr. Folta, you've made a career for defending genetic engineering. How important is the public acceptance of genetic engineering to the future of this planet?
Well, I've made a career defending science and now scientists, and I love where the evidence takes us, and we learn so much, and the stories are awesome. Such a cool time to be a scientist. And genetic engineering is one area in particular where when we have the ability to accelerate the process of plant genetic improvement, if we can do it more precisely, faster, and solve more problems, it is the future of agriculture.
But it's not natural. It's not natural. I love to bring up the example of the Lenape potato, which, of course, is a traditionally bred food product and resulted in a side effect that made it unsuitable for market. So, of course, I appreciate the difference. I myself spent a couple years doing IT at a crop and soils department. So I'm familiar with the old 1990s arguments. Oh, the pig DNA is going to infect you. You're not going to be able to eat anything without becoming a pig. And so there's a lot of popular misconceptions about the idea of genetically modified organisms that has started decades ago. And this is going off script a little, but like, what's your earliest memory seeing that there was this anti-science movement that might impact your work?
You know, that's a really funny question. I don't know the first time I saw the anti-science or the anti-technology side, but I know the first time I saw the pro-technology side. And I was 10 years old, and I read a book called Recombinant DNA and Downers Grove Public Library, 1977. And that book talked about how we'd be able to make insulin in big vats and how we'd be able to make growth hormone. And I thought this was such a cool thing to be able to cut and paste pieces of DNA like Legos, you know, that this was ultimately where we'd go. And I didn't think there would ever be any pushback. And there really wasn't in the 1980s when I was in high school and college. We talked about this all the time with really great forward-thinking excitement. And it really only started maybe at the end of my undergraduate time in the late 80s that you started to see a little bit of consternation around these technologies.
Can you speak to hybridization, how we do it, what its advantages are, disadvantages? Are we going to be able to replace hybridization with GMO?
Well, you know, there's a lot to unpack there, but if you think about tomatoes in the wild, they're growing all over South America, the upper part of South America into the Galapagos. They're out there. And those tomatoes are vines that grow on the ground without disease. They don't need fertilizer. They don't need water. They do just fine. Same with the wild strawberries that grow in the sand dunes in Oregon. Doesn't matter. Perfectly fine. The problem is that during domestication, we selected for the things that tasted good and the things that smelled good and the things that grew in our control. And when we did that, we lost a lot of these other genetics that made them bulletproof in response to environmental hostilities. So by making them better for us, we made them less as good as surviving for themselves. The good news is that all of those genetics exist out there in the wild in these repositories and makes it possible to be able to breed those traits into modern elite varieties, breeding something that has really strong resistance in with something that has reasonable flavors and aromas, and something that also doesn't mind the heat. They grow great here in Florida in the summer. And that's the beauty of hybridization. You're bringing in genetic variability across two entire genomes that is complementary and provides a good outcome. Usually when we're doing hybrids, we're combining two things that have been genetically introgressed. In other words, they're relatively genetically uniform. And so when we take the uniformity of one, which has absolutely horrible traits, probably on its own, and then you breed them against a different set of genes, which maybe are not such great performance for other traits. When you put them together, you get an individual that kind of gives the best of both, and does so because of the genetic variation that occurs in each genome. We call it heterosis. People call it hybrid vigor. The magic of that is seen only in the first generation, because if you can imagine, you have one set of chromosomes that look like one parent, another set of chromosomes that look like the other. In the next generation, you would see that mix, and you would see some individuals that might resemble one parent, some individuals that might resemble the other, and everything else a mix in between. And all you're seeing is the phenomenon of segregation, that genes moving independently in the next generation. Hybrids are awesome because of the genetic variation they get from two parents that then is very difficult to pass on in a stable way in the next generation.
Will we be ever able to get hybrid vigor in a GMO?
Well, usually a GMO is something that has a very well-defined genetic constituency. So you usually are taking two very poorly performing corn parents, for instance, that we know since making corn hybrids since the 1920s. Putting those two together gives you something really good. So 1 + 1 = 5. You know, that this set of genetics is not so great. Together, they're good. So that hybrid is awesome. So what they do when they make a genetically engineered corn plant is they put the genes of interest into one, and then they mate it against the other. And now that next generation carries that set of genetically engineered genes. And that next generation carries all the really good traits of the hybrid, plus this one little extra trait, or maybe 2 or 3 little extra traits. So the real winner in a genetically engineered plant is the basal plant that has been bred by traditional means. The genetic engineering just gives it a little bump over the top for a couple of traits you can't introduce by breeding.
So hybridization is going to be with us for a while.
Absolutely. Yeah. Hybridization and creating the mutts of the plant world is really the way that we're going to drive most major breeding efforts going forward. Genetic engineering is just a tweak. You're just making little adjustments to maybe 1 or 2 detrimental traits, or maybe adding a trait that you couldn't add by breeding. That's what classic transgenic GMO technology did.
GMO and hybridization are two different tools in the toolbox, sort of like energy storage and nuclear. You don't necessarily achieve maximal efficiency with only nuclear. You do have variation in demand, and so layering storage on top of nuclear is probably a really good thing. But storage by itself doesn't give us a lot, and hybridization doesn't fill in the cracks in terms of finding the traits that we need to maximize in our changing world.
No, you're exactly right. You're pounding a nail with a screwdriver sometimes. And so you got to use the right tool for the right job.
What about citrus greening? Is that a serious problem? And are we going to?
Yeah, so citrus greening is an incredibly devastating disease that's currently being seen worldwide. It's primarily been a real problem here in the state of Florida. Florida has a tremendous citrus industry, something like $10 billion a year. So this will be a major change that will threaten citrus going forward.
Is there a solution in advanced biotech?
I'm going to say no, there's not, just because we haven't seen one that has played out. The best technologies are slow to test and slow to approve. And so we're going back to the idea of hybrids, that there have been a number of trees that have been found like in an abandoned or a USDA breeding orchard where one tree is still alive. And they're using that now for rootstocks or scion material. All your citrus is clones. They're all stuck on rootstocks that grab the earth and transport whatever up to the top. The top is what makes the uniform fruit. And so they've identified some rootstock material. The University of Florida has something like 17 rootstocks that have now been trialed for close to 10 years and show that they confer some degree of tolerance to the disease. You get the infection, you don't die from it.
What you're talking about here is a greater variety in resilient root stock so that we can have this grafted agriculture product, much like our bananas, which won't go extinct one day when we have some kind of infectious agent among the trees.
That's a very nice analogy. I think to really give you a sense of the magnitude of the problem is that we do have a monoculture. Most of the juice oranges are Valencia and Hamlin, and both of these types of oranges very similar, just that they spread out through the season. So you have a juice that can be made from early season and late season. The problem is that you can't get the infrastructure that makes the juice, that transports the oranges, that packs the oranges in packing houses. You can't get that to turn on a dime. These are huge industries that went from probably 100 packing houses years ago down to maybe 2 or 3 now. And the problem that we have is that even if you came up with a great new orange that solved all the problems and lived through greening, the industry would have to completely readapt to be able to get able to handle it. And so it's not as simple as here's a new tree. Now you need 60 million of them. That's the first problem. And now you need to have an industry which can adapt its infrastructure to accommodate the innovation. And the tree takes how many years before it bears fruit? So it is definitely a problem. But, you know, we've got the best minds in the world on it, and which means I have nothing to do with it. Really, really good folks who are working hard at solving this problem. And I got great colleagues who are diving on it every day.
Are there major problems with industrial farming? We hear a lot of criticism about killing off insects with massive pesticide use and runoff then leaking into the oceans. Is there a natural alternative? Is organic farming the solution? What's the prescription here?
Well, you know, and that's a really challenging question because industrial farming, we're talking about is large farms. Large farms got to where they are because they're efficient. It's so efficiency of scale. And technology has improved in terms of on-farm technology for harvesting, planting, fertilization, all that stuff, to the point where we can actually have efficiency improvement. And when you have improved efficiency, it means more dollars for the farmer. It means lower costs for consumers, all that stuff. Part of that are crop protection strategies, which means the things that keep out the weeds, the pests, the fungus, insects. There are ways to do that, which by genetic engineering, we have cut the amount of pesticide that needs to be applied. And that's been shown very clearly in corn and cotton. There are other strategies to mitigate weed pressure that have been a vast improvement from where we are before. So these are new strategies from genetic engineering that have helped. But you're going to see this trend only increase as we start to see more sensor-based technology, more satellite imaging that tells this part of your field needs something, this part doesn't. Drones and rovers that scout for fungus and insects. You're going to see a lot more directed and precise use of chemistry that will really take the edge off the things that people complain about. So the future looks really bright.
The solutions that you're showing us is that efficiencies of scale and the application of technology is the real solution.
I agree 100%. I think the best way to ensure equity and access to the highest quality food is to keep the price down. And the way to do that is to implement technology through the experts who have decided to be the stewards of that technology, our farmers. I don't want to make, just because it costs a lot to fly and some people can't do it, that everybody should be allowed to be a pilot. I want to make the expert on the farm have the best technology to do the work that they want to do. Just because people could stick a tomato plant in the ground and see it grow doesn't mean that it's going to feed the world tomatoes in the winter. We got to make sure the technologies are being used by the experts who can use them, where they're being used. And if anything, we need more investment in domestic agriculture and more investment in domestic production. Let's make the farms bigger and better. Let's make them more enabled to produce more and more, keep the costs down for consumers, especially those who are food insecure.
Wonderful.
That's an interesting statement because I've heard that the small farms are much more efficient
Now, exactly the opposite. And my wife is a small
Nice.
farmer, and I can tell you about how
Yeah.
efficient it is.
Okay. I'm glad to hear that.
We farm fruits and vegetables, and I'm at the farmers market every Saturday morning, educating and sharing what we grow, and I love it. That's a great part of what we do on our place. But small farms, it's a whole nother challenge. And the advantage we have is if we can give people something they can't buy somewhere else because it just doesn't fit the modern supply chain, things like persimmons, or fruits and vegetables that if we grow it, they last longer. So they're actually getting a substantial value by buying from us. And plus, they know the producer. They can shake my wife's hand, they can say hi to me, and they know who the person is, where this came from. So they can come back and complain. They know who to talk to.
Yeah, it's a great way to go, but it's definitely not more efficient. I mean, longer rows, much more efficient. I often tell people who are talking about vertical farming, driving down 101 to go to San Luis Obispo, there are lettuce farms that at 60 miles an hour, it takes you 3 or 4 minutes to get to the next patch. It's the scale of farming is not well understood by the average person.
No, you're exactly right. And that's the gorgeous part of this is that when you can do it at such massive scale, the lettuce farmers out in the San Joaquin Valley, they're planting one big crop a year. And the ones down here in Florida who grow down by the Everglades grow one big crop counter seasonally when California isn't producing. And this is why we have lettuce around the year. But during that off time, they're doing something like sweet corn, or at least in Florida, or something else. The ability to focus on one major commodity has a lot of advantages. And especially when you're looking at things like feed corn or soybeans or sugar beets, some of these big commodities, your ability to focus on that one crop allows you to do this with great profit and fewer inputs.
Of course, it's more efficient in terms of labor, and especially for the majority of products in the staple food parts of America, we have relatively contracted labor markets, and it's being replaced by mechanized automation. Is it, in fact, much more efficient in terms of space, like you're talking about the long rows? And is it also more efficient in terms of, let's say, resources per calorie? So you're getting the choice between letting a crop area go furlough or cycling in more nutrients and then having a second rotation like you were just discussing.
Yeah, I think it depends on what type of farming you're talking about. I mean, when you say industrial farming, I think what we're talking about is large acre farming, which typically still are family farms. They could buy the land next door because someone wanted to get out of farming. It's hard work. It isn't very profitable all the time. And so you can do more because you have GPS driven tractors. You've got combines that can run from satellites. All these technologies allow you to do more with less. But I think as you go smaller, it does make it more challenging. And if you're going to be in the business of boutique fruits and vegetables like we are, it's my job outside of being a professor. It's what I do on nights and weekends for a good time. Have to do things at a different scale, but we can sell things at a cost that large farmers can't do. So that's why it's still economically feasible.
I do see all the time reference to permaculture, regenerative farming, eco-agriculture. What do you think of all of that?
It's tricky because a lot of this is driven by folks who think that they have solutions to the problems that you can overcome by ideas like intercropping and which is stuff we do too. The bottom line is if it works, we do it. And we don't have to put a fancy label on it or like regenerative or eco, whatever, agroecology. We're able to combine plants that fix nitrogen, plants that are cover crops, plants that we put in off season, plants that promote pollinators. We do that all the time anyway, and that's just called efficient farming. We don't need to put an exciting, trendy label on it.
You have nitrogen fixing crops and techniques integrated in advanced agriculture. Does this lead us to a future where we can have a large farm that has less use of fossil fuels, less use of nitrogen fertilizer?
No, that's a great question because nitrogen fertilizer starts with natural gas, and the Haber-Bosch process creates a fertilizer that can be applied exogenously. And what's going on now, and this is totally cool, two big pathways. The first pathway is there are many efforts to be able to create bacteria that are already present in the rhizosphere, in the root neighborhood of nitrogen fixing plants. And these bacteria can fix atmospheric nitrogen into ammonia and other nitrates that plants can take up. So this is one thing that's happening, and it looks really good. And big companies are doing it. There's all kinds of companies that have been spawned from this. The other thing is that in Mexico, they found a corn plant, that actually harbors bacteria on some aerial roots, these weird roots that grow out of corn plant up on the top. And it is a grass. So it grows these weird roots that have this exudate loaded with bacteria that actually fix nitrogen. So this goes back to the hybrid question. Well, what is happening in that wild land race of corn that fertilizes itself? And can we adapt the genetics to modern varieties to allow them to be able to harbor the bacteria that do that nitrogen fixation? Yeah, I think it depends on what type of farming you're talking about. When you say industrial farming, I think what we're talking about is large acre farming, which typically still are family farms. They could buy the land next door because someone wanted to get out of farming. It's hard work. It isn't very profitable all the time. And so you can do more because you have GPS driven tractors. You've got combines that can run from satellites. All these technologies allow you to do more with less. But I think as you go smaller, it does make it more challenging. And if you're going to be in the business of boutique fruits and vegetables like we are, it's my job outside of being a professor. It's what I do on nights and weekends for a good time. Have to do things at a different scale, but we can sell things at a cost that large farmers can't do. So that's why it's still economically feasible.
I do see all the time reference to permaculture, regenerative farming, eco-agriculture. What do you think of all of that?
It's tricky because a lot of this is driven by folks who think that they have solutions to the problems that you can overcome by ideas like intercropping, and which is stuff we do too. The bottom line is if it works, we do it. And we don't have to put a fancy label on it or like regenerative or eco, whatever, agroecology. We're able to combine plants that fix nitrogen, plants that are cover crops, plants that we put in off season, plants that promote pollinators. We do that all the time anyway, and that's just called efficient farming. We don't need to put an exciting, trendy label on it.
You have nitrogen fixing crops and techniques integrated in advanced agriculture. Does this lead us to a future where we can have a large farm that has less use of fossil fuels, less use of nitrogen fertilizer?
No, that's a great question because nitrogen fertilizer starts with natural gas, and the Haber-Bosch process creates a fertilizer that can be applied exogenously. And what's going on now, and this is totally cool, two big pathways. The first pathway is there are many efforts to be able to create bacteria that are already present in the rhizosphere, in the root neighborhood of nitrogen fixing plants. And these bacteria can fix atmospheric nitrogen into ammonia and other nitrates that plants can take up. So this is one thing that's happening, and it looks really good. And big companies are doing it. There's all kinds of companies that have been spawned from this. The other thing is that in Mexico, they found a corn plant, that actually harbors bacteria on some aerial roots, these weird roots that grow out of corn plant up on the top. And it is a grass. So it grows these weird roots that have this exudate loaded with bacteria that actually fix nitrogen. So this goes back to the hybrid question. Well, what is happening in that wild land race of corn that fertilizes itself? And can we adapt the genetics to modern varieties to allow them to be able to, can we do that by creating hybrids, or can we do that with genetic engineering? What if it's a gene or two that we can move in the lab to make it accommodating to those bacteria where they're taking the nitrogen out of the atmosphere fixing it and creating their own fertilizer. This is where the future is going.
Isn't it just possible to replace these processes with some kind of high labor crop rotation, or you just work harder and it'll all get better? Is that a solution?
No, there's no bandwidth for working harder. Everybody's going full throttle. Labor is way too expensive. The consumer doesn't want to pay for it. The farmers can't find it, even if it was available. So you have to have technology step in. You can do it with genetics. You can do it with other types of technology. But human labor in agriculture is something that definitely is in short supply and even going out.
But let's suppose for a moment, somehow we had enough labor to work on this problem. Would it be as effective in terms of space and resources as advanced technology?
It might approach that, but the problem is the ethics of, do you relegate human beings to doing work that doesn't need to be done? Hard backbreaking work that hurts, that is not good for people. You know, we could have the best minds working in solving bigger problems. If we could plug in robots, genetics, sensors, that's the way to go. We don't need to have people doing a job that a robot can do.
Very good.
Nitrogen fixing corn would be a game changer.
Yeah. Well, if you like that story, check out my podcast, the Talking Biotech podcast, in a discussion with Dr. Bennett from University of California, Davis. He talks about this landrace of corn that was discovered and the bacteria that it harbors. It has this weird mucilage that it produces that holds the bacteria, and it creates its own nitrogen fixation. Totally cool.
Yeah. Are you familiar with the RBT eggplant in Pakistan? Bangladesh, excuse me.
Bangladesh.
It's a great story. I love it so much because it's just that full trajectory from, oh my God, we've got this horrible pest, to, oh my God, it's gone.
Yes.
And I read that some of those guys were spraying 3 times a day to protect their crop, and in the end, they've got a mushy eggplant. I love the story from beginning to end.
and I would love to spend the 3 hours it would tell. It's a great story. You're 100% right. So the eggplant is a very important crop in Bangladesh and other places, India, other places, Philippines, very important. And it suffers from invasions of something called the root and shoot borer. And Bangladeshi or Bengal farmers would grow the eggplants and have to protect the eggplants with old school insecticides, things like carbamates, organophosphates, malathion, spraying out of one of those, things. No personal protection except for a cloth over their mouth. Usually kids coming out in the field to help, because if you're a subsistence farmer in Bangladesh, this is your crop. And you have to protect it with everything you have, or you don't eat, your kids don't go to school, your family stuff.
Life and death.
Life and death.
Yes.
So do I risk cancer and health effects in 30 years if instead of being able to eat tonight? That's an easy trade-off for anyone who's a parent. And so they would spray these things. The BT eggplant, this has a gene from Bacillus thuringiensis, a naturally occurring bacterial gene that produces a protein that destroys the larval stage of certain insects. And it's extremely targeted. It will take out the beetle. It will take out a butterfly, a moth, a specific type. And it targets the fruit and shoot borer. So if you take the gene from the bacterium and put it in the eggplant, once the fruit and shoot borer insect takes a little bite of that eggplant, it stops and it dies. So you decrease the population of them and you don't have the damage on the crop. This thing started with 2 farms, probably in 2014. Soon it was up to 14. Then it was up to 100. Now it's everywhere. Tons of farmers using it. Great success. India has banned it. India was originally offered the technology, and they said, no, we'll pass that GMO Franken stuff, right? Greenpeace made sure it didn't happen.
But what's her name was? Vanya Shadeva.
Vandana Shiva. Vandana Shiva said, this is a horrible thing. But the agriculture minister of Bangladesh, little tiny woman who is a scientist, who says, we'll take it. And she said, I want this for my country. I want this for my people and my environment. And they grow it very successful. And what's really cool is it's everywhere in India. It's illegal, but it's everywhere. And farmers are having these huge protests where they say, hey, we're growing it. What are you going to do?
And there's no way to tell if it's, it's like, gee, it's a perfect eggplant.
Or Tim, you can go to the hardware store and buy the BT spray, but the guy in Bangladesh doesn't have an Ace Hardware in the corner. Right. And he's buying from a local broker who might have counterfeit chemistry. It might have water in the cans. He might have DDT. Who knows? So by being able to use the seeds that are given away that have this natural protein that defeats that insect, this is a miracle. And it's funny that people get in the way of that.
By using that instead of pesticides, you're protecting the pollinators as well, right?
Absolutely.
I don't know. It's just inspiring as far as technology and advocacy, environmentalism. It hits every butt. It's just great.
It's being used in breeding programs because eggplant in India and Bangladesh is many different things. This is the center of diversity, and you find white ones, orange ones, purple ones. The purple eggplants, like we're familiar with, are big in Bangladesh, but now it's going to be approved in the Philippines, and that may be a little different too. So it is a great story. If you want to see something cool on the story, check out a documentary online called Well Fed. And the Well Fed documentary is a guy named Hidde Boersma. He's a scientist, a PhD scientist, but also a filmmaker in the Netherlands. And it's called Well Fed. It's in Dutch, but English subtitles. And it talks all about the Bangladesh story.
Are there any other solutions coming in through advanced agriculture?
Probably the biggest ones in the area of genetic engineering are in the disruption of genes that leave plants susceptible to disease. So this is an interesting thing. We usually think about disease as being resistant to disease, but plant resistance is a funny thing. There's an ongoing arms race between plants and the pathogens that infect them because they're stuck in one place in the ground. And so you have this constant arms race that's happening, and you actually have receptors that make a plant susceptible to many different diseases. So if we can disrupt that mechanism by which the pathogen enters, it's called CRISPR-Cas9. This is a new technology, 10 years old now, that allows us to really make directed changes in things like the susceptibility of plants to disease. Really a big deal.
Wonderful. We haven't really gotten to vertical farming yet, but I understand you have a bit of experience investigating how light affects plants. And so is vertical farming something that we can actually do efficiently? Is that at all in the future, in the cards for us?
It's in the future. How plausible it is in the future depends on a lot of things. Right now, a lot of investment is in that space, and I think it's not nearly as productive as people would like it to be. There's a lot of critics who say it's just destined to fail. But I think the major reason is because we're growing plants that were designed for the field in an internal environment. You're growing outside plants for the field in a box. And it opens up a new possibility for us to use plant breeding and genetic engineering to create the next generation of plants that are made for that environment. It's like winning a dog sled race with dachshunds. You can't do it. You got to have a machine that's made for the snow, that's bred for that environment. Long fur, big paws, strong muscles. So just like trying to get plants to grow in a weird environment, you have to have the right genetics for that environment. And I think we're getting there. And the field is finally realizing that. And I can't think of it very much from that side of, is this only going to benefit food producers, that kind of thing. What I do know, here's what I do know, is that this isn't an instead of, this is an addition to. And what you're seeing is smaller companies in urban centers using buildings that have been not used for decades. And they're able to repurpose those for growing plants, hiring local labor, adding to a tax base, doing good things, and then having food that's produced in Newark, New Jersey, getting on a truck that morning and going across and showing up in grocery stores in New York City. We're right now may be concentrated a little more for the affluent elite consumer. This is something that could have widespread benefit across economic classes. And if we could decrease the cost and the carbon footprint of food production and give something to families in my town, and I live in rural Florida, I go down to where people are buying fruits and vegetables without a car. They might be able to get an onion and a banana, maybe an apple fresh. So there are opportunities to be able to produce high nutrient density crops for the food insecure and for our food deserts. I think that is a residue that will come from these new technologies.
As someone who comes from a software engineering background, I see the field is ripe with intellectual property abuse of patent. Is this something that you see is a possible issue in biotech?
But those problems will always be there because that's how the legal system is structured with patent trolls, and they're taking advantage of an opportunity that's there. I think that right now I have students in my classes that in my molecular biology class that I say, the world is your oyster, and the job that you will take and the products you will create, it's not even invented yet. The things that are happening right now in medicine, the startups that are happening that are solving and taking on our most insidious diseases, they're using technologies that didn't exist pre-COVID. And between COVID and the pandemic and other technologies that were ripening rather slowly, this accelerated them and gave us some new opportunities to apply new strategies that weren't as acceptable and on the radar. The things like the mRNA technologies, nanoencapsulation, all kinds of other things that are happening in medicine that are just insanely beautiful. I think that you'll see many different cancers be treatable in an extremely aggressive way in the next 5 years.
Genetic engineering.
And
genetic engineering.
Yeah. A big part of it is genetic engineering. There are people on this planet right now who have been, and I'll use the C word, cured of sickle cell anemia. And that is something that would have been unheard of 10 years ago. And so this is very real, and this is where the future will be for medicine.
I've listened with great interest to what's been said. One of the problems seems to me that the legal system is always looking backwards. Scientific research is fantastic, but the legal system is most of the time is not helping us. And I look particularly at what happened in COVID. The capitalist system did a fantastic job of coming up with vaccines much faster and in much greater numbers than anybody ever expected. But then to roll them out for the rest of the world, oh my goodness, that's another problem. So that's one thing. Separate thing I want to talk about, and I'm really interested in this vertical farming business. Not tomorrow, but 150 years' time. It seems to me that if you have in vertical farming, you can have a nuclear power plant with unlimited waste heat, unlimited off-peak electricity for LED lighting. All the things that are holding back such farms at the moment would be almost free on site. And then there's no reason why you can't have strawberries at North Pole, except that it'll be all just ocean by then. But the geographical and the seasonal links of our farming should be broken. And that means that the whole business of migrant labor and farm labor, which at the moment is seasonal, which has caused enormous problems economically and from a human point of view and so on, that should all go, because either it'll be done with robots or it'll be done with people who work on it 365 days in a year and 24/7 for that matter. So we will get away from being victims of the weather and the latitude and longitude. And in fact, under these circumstances, with, as you said, the development of plants and organisms, which in fact we haven't seen yet, once they develop inside, we will end up by being that humans will be effectively nuclear powered. The environment will be effectively freed up for leisure and for wildlife, which can be, we can thinking about the needs of the wildlife itself. I don't see that we will be going on breeding animals and killing animals to eat. I think our great-grandchildren will think that was an exceedingly primitive thing to do, rather like slavery or something, and that will have been kicked out of the window. But clearly there will be enormous problems of isolating different vertical farms from one another so that there is no infection from one to the other. But anyway, I just wonder how you react to my looking that far ahead. It does rely on having enormous supplies of free energy, which I think we will have.
Well, and I agree 100%. I mean, and I would argue that right now, it's not a bridge too far. The biggest problem we've had is that we've had people who are geeks in technology with the lighting and the air conditioning and all that stuff really take precedent over those who are thinking about the most complex machine in the box, which is the plant itself.
Soil.
Right.
Yeah. And so, soil.
And or sometimes soilless. A lot of these places are using aeroponics or hydroponics.
Sure.
And so a lot of other good strategies. So I agree with you 100%. I think that my animal ag people would disagree with me here, that our future will probably be a lot less dependent on animal agriculture, that the environmental impacts, the costs. I think the lab-grown meat, other types of protein alternatives will find favor over the next 5 decades. It won't be right away. You know, I like a good ribeye as much as anybody, but I just imagine these practices do have a shelf life.
Good. Well, thank you.
Yeah, but nuclear, of course, is going to provide us 4 billion years of present demand. So we don't really need to rely on the sun to grow our food.
Nuclear desalination will make a much, much, much bigger difference.
In the next 30, 40 years, the importance of water is going to get more and more obvious. Right. And the solution to that will be nuclear as well. So I don't disagree with you, but it doesn't look like that at the moment.
Right.
Because
I live in California.
We don't. Oh well, yeah, okay, but
we're heading into our third year of drought.
I'm looking at the international side. I mean, there are countries which simply they don't have the money to invest and do these kinds of things. I think our political system going forward has got to be much more equitable between countries if we're going to make a success of all this.
If you have any closing thoughts, Kevin, why don't you go ahead and let us have those?
Well, I think that we just have not enough time to tackle all these issues in one shot. It really does make me excited to be part of the technology boom, not necessarily as a genetic engineer who's going to change things with genetic engineering, but as an educator who is excited to train the people in how to do this. That's my big role now. And then the other one is how to communicate about it and to inspire people about the beautiful stories like Bangladesh. You know, thank you, Tim. These are the things that will change the direction of the public perception. And I think it's all right there for us to do. And your podcast is a big part of that too. So thank you so much.
Thank you so much for your time, Dr. Kevin.
Thank you.
Folta. And instead of please support nuclear energy, why don't we say, please support GMOs? That'll be our message for today. The mission's first.
Emissions first. Peace and justice will follow.
Please subscribe to us on YouTube, Ecomodernist channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.